I'm sure there are students out there that can look at this problem and instantly just circle the correct answer right away and not sure why. Me, I'm going to need a little bit more of a pragmatic approach to this. And what I'm going to do first is write out the original expression. And then let's think about what these questions are telling us and what else can we do to rearrange this equation to best suit our visualization of what is going on in the explanation here. So what if the following must be true based on this expression is really what this whole paragraph is saying. 1, a temperature increase of 1 degree Fahrenheit is equivalent to a temperature increase of 5 over 9 degrees Celsius. So, a little bit over half of a degree Celsius. Well, thankfully, we see that 5 and 9 is already here. And let's picture something here. If we were, so what they're saying is a 1 degree increase Fahrenheit. So if this was originally 0, that would be negative 32 times 5 over 9, right? And so let me rewrite that as the next step. So 5 9 times negative over 32. 5 9 times negative 32. Now, let's say that this was 1. Well, then that would actually become negative 31 times 5 over 9. So what we see is that it's changing by only 1 5/9 because we're multiplying here. So originally, it was 32 5/9, and now it's 31 5/9. So it's changing by a 5/9, right? But remember, the answer is negative, but we're getting less negative, which actually means that we're actually going up in temperature. So increasing from 0 to 1 here actually brought us up by 1 5/9 here. So that makes 1 definitely true. What about 2? Well, they're talking about what if we were to change 1 degree Celsius? Is that equivalent to 1.8 degrees Fahrenheit? Well, the only way I can really figure that out is I need to get Fahrenheit by itself here. So what I'm going to do is I'm going to rearrange this expression where F is by itself. So that way I can really isolate the changes that's going on with F. So I can, since this whole parenthesis is being multiplied by 5 over 9, the function here is multiplication, and the opposite of that would be by timesing both sides by 9 over 5. So that would cancel out with that, the 9 over 5 here. So now we have 9 over 5 times C is equal to F minus 32. And then I can get F by itself by adding 32 to both sides. And then now I have 9 5 over 5 times C plus 32 is equal to F. And now I can look at this and ask myself, well, if I increase my Celsius by 1, let's imagine that, what's the effect that happens? Well, if this is 0, so this is 32 plus 9/5. If I bring it up to 1 here, I see that I'm now increasing the 9/5, how many 9/5 I have, by 1. All right, so is 9/5 1.8? Some of us may be able to know that right off the bat. And I can tell you that I personally would feel a little unsure about that on test day. So I can actually just remember how to do this old school. So then I'll say 9 divided by 5. What is that? Well, 5 goes into 9 once. And then we multiply minus 5. And that ends up with 4. And then I can just turn this into 0.0. But then this becomes 0. And then 5 goes into 48 times. So I now have 1.8. I'm going to make that decimal go up here. So 9/5 is the same thing as 1.8. And we see that it's going up by 1.8 every time we change the number by 1, right? So we originally had 1, now we have 2, or now we have 3. So an increase of 1 degree by Celsius will indeed change it by 1 degree Fahrenheit. So 2 is definitely correct. Now we look at 3. A temperature increase of 5 over 9 Fahrenheit is equivalent, right, to 1 degree Celsius. Well, we saw earlier that going up by 1 degree Fahrenheit gives us a little bit over half of a degree Celsius. So 1 degree Fahrenheit increases by about half a degree Celsius. And now they're saying, what if we did half a degree Fahrenheit? We'd go up a whole degree Celsius. That's totally off. There's no way that can be true because 1 Fahrenheit doesn't even get us all the way to a Celsius. And now they're saying halfway through a Fahrenheit definitely gets us to a way Celsius. That doesn't make sense. So then now we're just left with 1 and 2 being our correct answer, which is D.